And now, without further ado, our amazing speaker, Holly Cummins, directly from the UK. Holly is a senior principal software engineer and a Java champion. Holly started her career as a performance engineer, making the J9 JVM go faster before it became Open J9. Holly, thank you very much for being here with us.
Well, thank you so much. I'm delighted to be here. I'm
We are
just
very
sorry that
excited
I'm
to
not,
have you.
yeah, I'm just sorry that I'm not there in person so that I can't go on the dodgems. But
No problem at all. The stage
yeah,
is all yours.
thank you. So I want to talk about innovation, and I want to talk about innovation, and I don't want to talk too much about myself, but I do want to give a little bit of an introduction to give some context for the stories that I'm going to tell. I work at Red Hat. I'm a senior principal software engineer at Red Hat. I'm helping to build Quarkus. I've only been at Red Hat for about 2 months, and for all the rest of my career, I've been at IBM. And most recently, I was a consultant in the IBM garage. And so our mission was to help large enterprises and also teeny tiny startups take advantage of the cloud and innovate. And those two often go together, of course, because the cloud is a great way of unlocking innovation. And so working with those businesses, I saw lots of amazing innovations, but I also saw some things where I thought, there was a lesson learned. We should have done something a bit differently there. And maybe we'll try and make sure that never happens again. But stepping back from IBM and my work there to innovation in general, one of the fascinating things about innovation is that the very best ideas, when they were first introduced, seemed somewhere between impossible and completely stupid. But the sort of the tricksy thing about innovation is that now we look at them and they just seem perfectly normal. And a lot of these sort of things that seem impossible happen because everybody knows you can't do something. Everybody knows something works in this way. And if we can come along and challenge that everybody knows, we can do something amazing. And I see this in my day job all the time. So as Ricardo mentioned, I started my career as a performance engineer working on the JVM. And one of the questions that I got asked all the time was, couldn't we do ahead of time compilation? Wouldn't Java be much, much faster if we did ahead of time compilation? And the answer, which was kind of surprising, was no, actually, doing the compilation and the garbage collection dynamically in Java actually makes it go faster than it would if you did it ahead of time. And we did actually have ahead of time technology, but it wasn't worth it because it made everything slower. So why would you bother? So that was 15 years ago. If you fast forward to now, I think everybody kind of understands that the JIT and those kinds of things actually give Java a really big performance boost, and Java will outperform a lot of other languages, and it's because of those runtime optimizers. So then it was a real surprise when people started talking about changing how we did Java and doing a lot more upfront, doing a lot more at build time, but actually doing a lot more at build time now makes it go faster. And of course, that's not because we were wrong 15 years ago. It's just that the world changes, the technology context changes, the way we use things change, the cloud has changed our requirements, and then that's changed the right answer. And so it means that ideas that seemed stupid then turn out to not be stupid, like ahead of time compilation. But of course, we see this sort of everywhere, not just for Java compilation, but all sorts of innovations seemed ridiculous at the time. And now we just can't imagine life without them. I love this quote from the New York Times. I'm going to read it in full, just because it's so absurd now. And this wasn't that long ago. This was in 1985. The New York Times, laptops were starting to be introduced. And the New York Times said, people don't want to lug a computer with them to the beach or on a train to while away hours. They would rather spend reading the newspaper, like the physical paper newspaper. Somehow, the microcomputer industry has assumed that everyone would love to have a keyboard grafted on as an extension of their fingers. It just is not so. And of course, here's my phone. And we all, now I feel quite anxious if I'm more than about 5 feet away from my phone. And we're so accustomed to really spending all of our time on some kind of computer that the idea that just 40 years ago, this was a really stupid idea, that people thought, oh, it's just the industry trying to push something on us that we don't want, goes to show how sometimes things that we now take for granted seemed absurd when they were introduced. A slightly more low-tech example is that when bicycles were introduced, there was a little bit of a fad, but then everybody thought, oh, this is just a fad, this is just like the scooter, And in 1906, the Washington Post said the popularity of the wheel is doomed, which is just one of those quotes that you just want to forget that you said because it's so very wrong. Going even more low tech, because innovation happens everywhere, not just in computers. The idea of putting cheese on a hamburger, and now, I can't even imagine having a burger without cheese. In 1947, when this was started to be done, the New York Times again said, the combination of beef with cheese may seem bizarre. They thought it was some weird thing that they did out in California that the rest of the world just didn't want. And I think, there's all sorts of these stories, I could go on and on and on, but I won't, with, examples of ideas that seemed really stupid that we now take for granted. But there's a bit of survivorship bias in there because, of course, there's a whole bunch of ideas that were introduced and seemed really stupid at the time. And that's because they actually were really stupid. I want to talk a little bit about George Washington Carver. I think he's quite well known in the United States. I think he's less well known outside the United States. And in the United States, what he's most famous for is inventing peanut butter, which is kind of funny because he actually didn't invent peanut butter, but that's sort of by the by. He was an incredibly successful inventor. So he was sort of born during the Civil War in the United States, and then he sort of went on to pioneer really a huge amount of educational progress. So he was the first African American to earn a BSc. When he died in 1943, they gave him a national monument, and this was the first person that they'd ever given a national monument to who wasn't a president. In 1943, when he died, they also named a ship after him. So there was the SS George Washington Carver. And more recently, he was inducted into the National Inventors Hall of Fame because of his accomplishments. So you imagine that's someone who gets it right all the time because he's such an amazing inventor. No, he had very many successful inventions, and I'll talk about some of them later on. But he also had some inventions that just not so great. So he invented peanut bread, and that was He invented the peanut sausage. He invented peanut coffee. Well, he invented peanut-based paint. And most worryingly of all, he invented peanut nitroglycerin. So that's basically peanut-based TNT. Did not succeed. So if someone like George Washington Carver, who's in the Inventors Hall of Fame, who's so successful, has all of these stupid ideas, how does anybody tell the idea between, it seems kind of ridiculous, but it's going to be amazing, and no, this is just ridiculous? So if you've been paying any attention over the last 5, 10 years, you know the answer to how do I decide if my innovation is good is to build an MVP. An MVP stands for minimum viable product, but I often see it used slightly differently. So often instead of minimum, it ends up being the maximal viable product. Or sometimes we go the other way and it's not really a product at all. It's just the minimum viable prototype. Sometimes it's the modestly visionary product. And I think this is a problem because it means that if I say MVP and you say MVP and someone else says MVP, the reason we all say MVP is because we want to try and communicate about what we plan to do. But because MVP means so many different things, it means we're not really communicating at all. So I feel like MVP as a phrase, I will be happy if I never talk about building another MVP again, because I think now it really is this sort of minimally valuable phrase. It doesn't really do what language is supposed to do, which is get a shared understanding of what we're going to do and why. And I really started to realize that we had a problem talking about MVPs when once I was working on a project and they said, our MVP has been through 5 architecture review boards. So we haven't written any code yet. We've been through 5 architecture review boards, but we're going to start coding soon. And I thought, that's not lean in any way. That's not lean startup. That's not anything except for waterfall. And yet we're putting this word MVP on it. So why? Another time I was in a workshop with a client and he was doing a startup and we were working really hard to try and scope down, because that's one of the things that you do with the lean startup methodologies. You try and find the smallest possible scope. And so we were sort of saying, oh, is this essential? Oh, I don't think so. I think maybe we could do that later because that's not really going to be critical to deciding if we have a business here. And at the end of all of this de-scoping, after 2 days, he looked at all of our boards and he said, well, yeah, that's nice, but can you make it bigger? Because I want a $12 million MVP. And to my mind, it's $12 million is not an MVP. But again, it's not that he was wrong. It's just that we had such different understandings that MVP wasn't helping us in any way. So now what I really try and do is instead of talking about MVP, I try and be explicit about what we're trying to accomplish. So is this just our first release and we're calling it an MVP? Is this an experiment, which is more of a classic MVP where we're really focused on learning? Or is this our first release, but we're using MVP as an excuse to not really worry too much about quality or testing or anything like that because it's kind of boring and we think if it's an MVP, we're allowed to. And again, all of those are okay, depending on the context, except maybe not worrying about the quality. But we need to know, because if half the team thinks we're doing something that has poor quality and half the team thinks we're doing an experiment, and it's just going to be a mess. I want to share a story of what I consider to be, again, there's lots of different definitions of MVP, and I'm not sure any of them are exactly wrong, but this is my favorite, my personal favorite, which is that we worked for a company called Mueller. And Mueller, it's not Mueller, the yogurt company, which confused me a lot when we started working with them. They're an American company who do construction equipment. So they retail construction equipment to builders. And so when we did their MVP, we sort of did a sort of a classic development flow. So we did the visual designs, then we did the user research, we did DevOps. As soon as we started coding, then we had this responsive web app and we were doing TDD because we wanted the quality to be there because this was going to get released out to the public. And so then we deployed to prod. But the one thing that we hadn't done was the automated system for taking the orders. And so when someone would use the web app and they would place an order, what it would do is it would send an email to the seller from the app, who would then process it the way that they had always done it. And this seems, it sort of makes me itch a little bit, because how can you have an app that doesn't have any kind of automation behind it? But what it did was that if nobody used the app, if nobody wanted to buy materials in this way with the app, because what they had done is they used to sort of ring up. If people didn't use the app, we didn't have a problem that we didn't have a back end, because no one was using it. If people did start using the app, that load of processing all the emails was going to get kind of tough for the seller, but that showed that we were onto a winner. And so then we could quickly go and do that next phase of investment. And so this is called a Wizard of Oz MVP. And it's named after the sort of the bit in Wizard of Oz where they say, pay no attention to the man behind the curtain. And so it looks like a really modern thing, but then underneath, there's sort of two hamsters on a scrabbling on a wheel. And again, what kind of MVP you want to do is going to depend a lot on the business context. So there is no one right answer. If you're in an environment of high uncertainty, that's when you want to be doing these kinds of experiments. So you want to be doing something where the answer could be, yes, this is a great idea, but really it's designed to be able to fail. And so then you really, in order to know if it's failed or not, in order to know what the answer is, you need really strong metrics. And the focus there is learning. Once your experiment, if your experiment succeeds, then you go on and you do the follow-on experiment. But it's really focused not on building something complete, but on maximizing your learning, which may not involve building anything with code at all. It could just be doing some kind of test to figure out if the technology works, to figure out if the user demand is there. Once you are in an environment of less uncertainty, so perhaps you've done your experiments and you can go on, or actually you're already pretty confident, then you go to more of an iterative, agile, incremental model where you still want to be doing small things. So you want to do that radical de-scoping and you want to focus on user value. And then you do continuous rapid iteration to get that scope bigger and bigger while getting value to your users as often as possible. And then of course, those two are connected. So once you've done your experiments, then you can go on to do your build. But the metrics part can be tricky because a lot of us will now say we have a data-driven business. And often, there's a lot of numbers there to back it up. But how do we interpret those numbers? Often how we interpret those numbers is no matter what the numbers show, I should get promoted because it shows I'm doing a good job. And so we don't really end up in the situation that we should be in, which is the numbers tell us what to do and we make quite different decisions. We go this way, we go that way, depending on what we're seeing from the numbers. And so if the numbers always tell us we're doing a good job, then they're what we call vanity metrics. And I like to call them magic numbers because they look like numbers, but no matter what they are, they say you're doing a good job. In order to have more meaningful numbers, in order to have that learning, you really need an environment with psychological safety because you can only get learning if your experiments sometimes tell you what you didn't expect. And that's going to be uncomfortable. And you need to have support for that all the way through the organization. So you need to be able to go to your leadership and say, yeah, we tried this experiment, it didn't work, and it didn't work. And if that happens, it can be disappointing, but it shows that we're asking questions that we didn't already know the answer to. And that's a good thing. And this doesn't mean that we did anything wrong. Sometimes even really good ideas are bad ideas if the timing's wrong, like ahead of time compilation 15 years ago. So going back to George Washington Carver, what he's most famous for, what most of his research was on, is improving the soil quality. And he started doing this because he he did most of his education in the north of the United States. And then he traveled to the south to take up a university teaching position. And when he was on the train, looking out the windows, he could really almost see this line when he went from the north to the south. And the fields had been green and lush in the north. And then it was almost like a desert in the south. The land was scarred and exhausted. And he said everything looked hungry: the land, the cotton, the cattle, and the people. And so he wanted to try and find a way to improve the soil fertility and to help people actually make, because the problem was people couldn't even make a living on the land because the soil was so barren. And so one of the first ideas he had, which he knew from his agricultural training, is that everybody was using a single horse plow. And with a single horse plow, you can't go too deep into the soil. And so you end up just turning over and over the top layer of soil. And he said, if you had a 2-horse plow, you could farm in a much more sustainable way. You'd get deeper into the soil, and you'd get a much better yield. And so he printed out a bunch of pamphlets that said, hey, farmers, I have an education. What you should do is you should buy 2 horses. And the farmers went back to him and they said, you may have noticed we're starving. We can barely afford to feed ourselves. We can't buy a second horse, no matter how good an idea is. And so the problem was that George Washington Carver had thought, the problem I'm solving is how do we improve the soil fertility? But actually, the problem he had to solve was how do we improve the soil fertility with no extra resources at all? And that's quite a different problem. And that's why his first solution didn't work. So, of course, what we want to be doing is we want to be discovering that this is a problem early. So in the case of the 2-horse plows, luckily all George Washington Carver had done is print some pamphlets. So there wasn't a huge outlay. But in general, when we're looking at it in an organization, we want to be having an innovation funnel so that we can try and we start out with an idea. We want to end up at production, but we definitely don't want all our bad ideas to end up at production. We want to, as early as possible, discover which ideas are bad. Unfortunately, what often happens is what I call the innovation railroad, which is that we start with the ideas and we don't ever give ourselves the opportunity to discover whether the ideas are bad or not. It will look really embarrassing if we halfway through this process admit that we had a problem, that it was a bad idea. So we just keep going all the way to production. And of course, that doesn't mean the failure is not going to happen. It just means the failure is going to happen in production when it's a lot more embarrassing and a lot more expensive. Another thing that I sometimes see, which I think is just as bad in a different way, is what I call the innovation fizzle. And this is where we have a whole bunch of ideas and we invest more or less the same amount in them, but then none of them get to production. They all sort of get prototyped, and then we're somehow unable to cross that bridge to, okay, how do we actually get it to production? But of course, even if we're not doing an innovation railroad and we're not doing an innovation fizzle, there's still a problem. Innovation funnels themselves aren't necessarily perfect. Sometimes when we're filtering, we can end up having a lot of paperwork and a lot of, sort of innovation review boards and that kind of thing. And we're focusing on trying to find something that's guaranteed to succeed rather than something that maybe will be really exciting, but a bit more risky. And that usually is a symptom of a lack of psychological safety in an organization. Nobody feels able to take risks because the consequences are so bad. And the innovation fizzle, I often see associated with siloed innovation teams. That, in principle, a dedicated innovation team seems like a really good thing. We want to be investing in innovation. I think there can be some downsides to it, though. So George Washington Carver, as I mentioned, most of his life dedicated to studying peanuts. Why was he trying to find like peanut uses for peanuts, like peanut bread and peanut TNT? It has to do with that soil situation again. If any of you garden, you'll know that things like peas or soybeans or peanuts improve the soil. So they're able to fix nitrogen. And peanuts, confusingly, they're called nuts, but they're actually not a nut, they're a bean. And that's why they're in this list. And the problem with the soil in the South was that generations of cotton farming had completely exhausted the soil. And Carver worked out that planting beans, like peanuts, could restore the soil. And so he worked out that if you rotate the crops, then you can grow the cotton that you want to grow because that's your cash crop. But your yield will be higher if the year before you had peanuts on that field. So you go back and forth, you have your fields, half peanuts, half cotton, back and forth, back and forth, back and forth. So this was working well, and the farmers were really happy with the cotton yields that they were getting. They were much higher. But there was a problem. Peanuts. All of a sudden, farmers had all of these peanuts that were coming in. And at the time, peanuts were not considered a valuable crop. Peanuts were barely considered a food. And so what Carver was able to do was show peanuts are nutritious. You can eat these things. And hey, you could eat peanut butter. You could have salted peanuts. You could have chocolate covered peanuts. He worked out all of these things that you could do with peanuts. And so then he turned this problem of, we have so many peanuts, this is a nightmare, into something where actually you're starving and you have an enormous pile of peanuts. We've just solved 2 problems by doing the crop rotation. And I find this so magical, really, because he'd taken something that was a really bad situation, and it's like 1 + 1 = 3. We sort of improved the soil and we got a whole bunch of food as well. So it's this double win. And I think the exact same thing works for people, because I think when you have an innovation team, it's like an innovation monoculture. They end up not really sharing the benefit of the innovation with the rest of the organization, and they don't really get the input that they need from the rest of the organization. So with the cotton and peas, if you didn't rotate the crops, you'd have a really bad situation. You'd have, if you just sort of keep going and you keep the cotton on the same field, your yields will still be terrible. And meanwhile, on the other side, you have all these peas that you don't need. And if you do the same thing with an innovation team, where you have the rest of the team continuing to sort of be burned out, and then you have the innovation team having fun, you won't see the benefits in the organization that you would otherwise. And I think it can be really frustrating for everybody else in the team to look over the wall at the innovation team, because what often happens is an organization will quite correctly recognize that innovation needs time, but then they say, and money and space, and they say, we wouldn't want to give that time and money and space to everyone in our company. Oh, no, we'll just give it to the innovation team. And the rest of the team is going, but I have ideas too. I could quite use some time and space. And I think what we see, I think probably everybody knows this, is that, if you're working really hard, sometimes a change is as good as a rest. And so we want to harness that effect for both the people in the innovation team who are maybe just having lots of ideas without any input from the real world, and the rest of the organization who are working really hard without any opportunity to have ideas and have that change. So one way you can do that is you can rotate people in and out of the innovation team. There's a whole bunch of other things that you can do as well, like you can have 10% time, which I think is not super effective. One of my favorite techniques for this is to have regular periods where everybody's free to do what they want. The project managers step back and they say, You all do what you want. So what we used to do, I used to, when I was developing WebSphere, was we had fairly infrequent releases. So it was a big rush and push to get to the release, and everybody would be tired. And instead of giving us time off, what our management would do is say, for the next sprint, we're not going to tell you what to do. You just go do something that seems useful to you. And it was so valuable. We cleared up so much technical debt in those, but also some of the most innovative, fun, valuable product features came during those weeks. And it seems like it's really rough to say to a team, hey, you've been working really hard, and so as a treat, you can continue to work. But we loved it. We were so refreshed. And I think it works, unlike a 10% day, because everybody's off at the same time. Another thing you can do, just more generally, is just make sure that those resources and those rewards and incentives are available for the whole team. And that means you have to accept risk from the whole team, not just the innovation team. The final anti-pattern that I want to talk about is the fauxnnovation. I mentioned that a lot of organizations say innovation needs time and it needs that budget. And we wouldn't want to give that to everyone in the company. And the corollary of that is that there's no slack in the system. There's no extra money for normal improvements, but there is sometimes a lot of money sloshing around in the innovation budget. And so what I used to see as a consultant in the IBM garage is quite often a company would come to us and they'd say, 3 years ago, 4 years ago, it was chatbots. Everybody said, we need a chatbot. And we'd say, okay, well, what problem are you trying to solve? And they'd say, we can't find anything because our internal search is really bad. And so if we have a chatbot, we can use that as an excuse to fix the internal search, which is the actual problem that we should be solving. We don't even need the chatbot, but it's an excuse to do it. I saw really similar things with blockchain, where when we'd say, okay, well, what problem are you solving? Why do you think you need a blockchain? It would be because we need to digitize our processes. You can digitize your processes all day long without a blockchain, but blockchain was the excuse that made that actual business as usual improvement possible. So what was happening was that these sort of normal improvements that were less exciting and glamorous, like digitizing or having search that works, were kind of being smuggled in underneath the disruptive innovation. The disruptive innovation would get thrown away at the end, but the business would have the benefit of that improvement. And so it kind of seems really negative, like that, this Trojan horse and we're smuggling stuff in, but actually we were smuggling in good stuff. So I think it was kind of more that we were enabling the innovation. And so actually I thought of it as a Trojan horse where we're sort of smuggling in the improvement, but it's almost more, it's like it's a sheep in wolf's clothing. So it looks like we're doing this really exciting, edgy innovation. We're doing blockchain, we're doing chatbots. It's so cutting edge, but actually we're doing something more ordinary that's kind of disguised as an innovation. And I think maybe that's okay. We sort of have this wrapper of innovation, but when we take away that wrapper, what's left is something that's good for everybody. So I think it's worth being aware of this pattern. Maybe if we see this pattern, we sort of think, okay, well, why is this happening? Why do we feel unable to sort out our internal search without a chatbot? Why do we feel unable to digitize without blockchain? Are we measuring the right things? So I think if you take anything away from this, I don't think I'll succeed, but I would say, don't say MVP, say what you actually mean. It will be much more useful for communication. Do think about what experiments you can do early and what measurements you can do early, but those measurements have to enable decisions. You have to act on what you find out from the measurement, not just charge forward. Innovation is a wonderful thing. It's something that should be made accessible to everybody in the company, and the results will be much better both for the innovation and for everybody else in the company. And finally, think about whether you're using innovation to enable things that you should be doing anyway, but you needed the excuse of the shiny technology. And with that, I'll stop. And I think we've got some time for questions.
Thank you very much, Holly. Wow, actually, I actually had some ideas to how to manage my team after this talk. So thank you so much for that.
Hooray!
Really amazing. And by the way, George Washington Carver, yes,
yeah,
amazing story as well. So really cool. We have actually one question from our Slido from Paul. When you decide to reduce quality in development on an MVP, for example, fewer or no tests, no TDD, and less clean code. When do you decide to reduce the quality in development?
Yeah. So that's a really good question. I think quite often when we do, I think reducing quality should probably be a last resort. So what I think it's worth reducing quality if you're fairly sure that, or if there's a good chance that what you're building is going to be throwaway. So if you think most likely it's going to go out to production, don't reduce the quality, because it's so much harder to put the quality in later. And I think TDD is expensive, but manually fighting regressions all the time is expensive too. So quality is worth having in. But on the other hand, if you know something's just maybe going to get shipped, maybe not going to get shipped, having all of that time spent in testing is probably a waste. So what I would normally try and do, if you think of it as like, you can squeeze in either direction. So you can sort of squeeze the quality, and then you end up with something that has all of the features, but you're going to have a lot of work later on to add back the quality. I try and say, can we squeeze it in the other direction instead? So what is going to make the difference between this going to production and not? Sometimes you can only find out by building the whole thing, but could we build a smaller bit of it and maybe do it with the decent quality, but then we stop? So for example, with an AI project, for example, often the thing that's going to make or break it is the model, is the capabilities of our AI engine. So like with a chatbot, for example, if it can't understand what we're saying, it doesn't matter what else we have around it. So can we do just that? Maybe expose it to real users, but expose it to real users in a cheaper way so that we can get that feedback. Or a lot of a classic other one as well is we don't start building code, we just do the visual designs and the user research to find out. But what I really like, my favorite, is the ones like what I spoke about with Mueller, where we have something that seems feature complete, but then we're having to do a lot of manual work if it takes off. And the Zappos, the classic lean startup story, is exactly the same. So when he built his business, he went out and at the time, it's sort of hard to remember, at the time, selling shoes on the internet was a ridiculous idea. And now I haven't bought a shoe in a shop for years. And so everybody knew you could sell books on the internet, but not anything that needed to be tried on. So he had this sort of the front end that looked the business. But then he didn't have any investment in infrastructure for his logistics or warehousing or anything like that. And so if someone would buy a pair of shoes, it would be the same thing. He'd sort of get like a little notification that there was a shoes, and he would go out to a local physical in-person store, buy the shoes, probably at a big loss because it was online pricing versus in-person pricing, manually pack them up and post them out. And so he'd go, oh man, I just lost $20, but I learned that this business makes sense and people want to do it. And eventually he was losing enough money that he could go and say, okay, look, we need to, it's worth investing in that whole system because this is working. So I'd sort of, try and squeeze that way. And sometimes if we think really clearly about, okay, what do I need to know if this is worth doing? There's so much other stuff that we can get rid of, that we do just because it's sort of a software engineering habit of like, of course I couldn't do a front end without having a solid back end, because that would be, icky. And it's like, okay, well, maybe we could, instead of being icky by not having the tests, maybe we could be icky by only having half of the system and having the other half be fake.
All right, we have two more questions in very, very little time. So how do you balance, from Fabian, how do you balance innovation and productivity when both are so important?
Ooh, I think, yeah, I mean, that's such a good question. I don't think anybody knows the answer. So you can see, sort of metrics for like, you should have 3% of your budget on R&D and that kind of thing. I think a lot of it is about looking around as well. And if you start to see that you're getting out innovated, then you need to increase the investment.
All right. And from Anonymous, so let's say that this is a person that don't want to be, don't want her name here. How do you identify vanity metrics? How can you improve them to give a real value feedback?
So there's
sorry, to
oh.
give real and valuable feedback. I said it wrong. So how do you identify vanity metrics, and how can you improve them to give them real and valuable feedback?
I think there's probably a simple test that you can do for the vanity metrics, just by sort of watching when you share the metrics, does a decision get made? Do we change course? And if we never ever change course, that's a good indicator that they're vanity metrics. But I'd also recommend, there's a book called How to Measure Almost Anything, which gives a lot of insight into how to find the metrics that are actually going to tell you what you need to know, rather than just sort of looking like a number but not enabling decisions. So that's good for the reading on that.
Thank you very much, Holly. This was very inspirational. I mean, I learned even not being a tech head, I could really understand everything too. You really made it easy for everyone, and the concepts were awesome. Thank you very much for being here with us.